Hey guys, and welcome back to the Real Numbers course. In lesson 16, we're going to continue our discussion of decimals. And remember, decimals are the key to understanding the real numbers in all their glory. All right? So we're getting close. We're very, very close. So let's make sure we know where we were. In our last lesson, we picked up a whole bunch of important information about decimals. Like, for example, we know what they are. They're just fractions in the tens family, like tenths, hundredths, thousands, yeah? We also noticed that, well, decimals then are just a fancy way of writing those numbers, right? A special way to write them. So 0.739 is just a way of writing. Notice the 9 is in the thousands place, tenths, hundredths, thousands, yeah? So we know we're dealing with a fraction in the thousands, and the 739, that's our number, 739 thousandths. How about this crazy thing? Let's figure out what that decimal means. Well, we need to figure out the place that the 3 is in. That's the last digit. So tenths, hundredths, thousands, yeah? 10,000, 100,000, millionths, yeah? 10 millionths. That 3 is in the 10 millionths place. There's our denominator. And how many? 3. You got it. Good. We also talked about how we could compare decimals to a half. Is it bigger than a half, less than a half? And the secret, it turned out, really had to do with the tenths place, because 1/2 in decimal form is 5/10. So 0.5. So if you look at that tenths place and it's 5 or higher, and other stuff happening in the digits that follow it, you're looking at a number that's bigger than a half. Okay, 5 or bigger, that's bigger than a half. If it's less than 5, then that decimal is less than a half. All right, this guy's clearly bigger than a half. You know what? I forgot to mention this in our previous lesson. We could also use this idea about how important that tenths place is to get a sense if our decimal is close to 0 or close to 1. And that turns out to be pretty helpful number sense wise. So it turns out if you've got 0.0, blah, 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 doesn't matter what comes after it, or 0.1, blah, 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 again, don't care what happens after it, then your decimal is going to be very close to 0. Likewise, if you've got a decimal that starts 0.8 and then blah, 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 keeps going, or 0.9, blah, 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 then that decimal is close to 1. All right, so for example, 0.90132, well, that's super, super close to 1. Looking at that tenths place, right? And if you have 0.0857, well, look at that tenths place. I don't care about the 8 and the 5 and the 7, even though they're pretty big. Guys, that decimal is close to 0. All right? So our understanding of fractions really helped us push forward and understand these decimals. Let's keep going with that. Let's keep going to the fractions for help in understanding these decimals. Like, for example, 0.70. We understand that is 70 hundredths, but that's a fraction that can be simplified, right? We could factor out the 10 tenths. 7 tenths times 10 tenths is 70 hundredths. Well, if we factor out that 1, that's not necessary. 7 tenths times 1 is 7 tenths, also known as 0.7. So what we're really saying is 0.70 is the same as 0.7. 70 hundredths is the same as 7 tenths. They're equivalent. But that turns out to be really super important and generalizes. It turns out, see that 0 at the end of 0.70? It's not changing the value. Zeros at the end of a decimal don't matter. They don't change the value of the decimal. So for example, 0.70180, see that 0 on the end? It's not doing anything for the value. It's equal to if you just had 0.7018. That's it. Okay, that 0 on the end isn't doing anything to the value. Likewise, if you got more than just 1 0, like you could have 3 zeros on the end or 30 zeros on the end, it doesn't change the value. So 0.349000, that's exactly the same as 0.349. All right? Now you do have to watch out. Consider this, 0.3 is not equal to 0.03. So that 0 that you see down there, that matters. Why? Well, it's not on the end. It's sort of pushing. It's in the number itself, and it's pushing the 3 down into the hundredths place. We want the 3 in the tens place. So no, some zeros matter, but zeros at the end, forget about it. All right. So here, just to practice that, let's talk about what's happening here. Consider the number 0.81. So 81 hundredths. Look down below. There are 5 other numbers, and we just want to circle the ones that are really equal to 0.81. All right, well, let's just take them right in line. This first one, 0.081. Nah, that 0 is not at the right end of the decimal. So it's changing it. See, 81 hundredths, and now in the first one, we've got 81 thousandths. That is because that 0 is moving in the wrong, in a spot that does matter. Those numbers are not equal anymore. I know it doesn't tell us to do this, but I'm going to cross this one out. That's not the same. That is not equal. How about the second one? 0.81 and 0.810? Good. You guys were already saying yes. That's right. That's just like our first example, right? We're just adding a 0 onto the end, the right end, and that does not change the value. So that is, in fact, the same number. Wait a minute. Who put this third one in? Come on. I apologize. I don't know how. All right, find out who did it and give me their names, okay? 0.81. How could that possibly be the same as 8.1? Come on. They're trying to get one past us. We know that that's not equal. Come on. All right. How about this fourth one? 0.801. Now that 0 is not on the right end. No, it's pushed in the middle, and it's separating the 8 and the 1. Bumping that 1 down into the thousands place. No good. That is not equal. Okay? Zeros on the end, on the far right end, they don't matter. So that last one, you know what? Look at all these zeros on the right end. You betcha. That is the same. So those two circled numbers are the same as 0.81. Nothing to it. All right. Let's turn to comparing decimals, which turns out to be super easy. It's kind of like putting words in alphabetical order. If you remember doing that way back when. You just line them up. You line up the decimal points, and you just start going left to right, and that's how you tell which is bigger. So notice, here's 2 numbers, and you're wondering which one is bigger. Now, I'll tell you what, the top one is certainly longer, but let's see if that matters or not. So just go through, like start in the tens place. Compare them. If they're different, right away you can decide about the whole decimal. But right now it's a tie, right? They're both 7. So, okay, we got to move to the next place, to the hundredths place. Now we got 3s in both places. It's a tie. Move on to the next place. Still a tie. Move on. Wait. There we go. Okay, the first time we see different digits there, game over. 2 is bigger than 1. So that bottom number, forget everything else that happens after that. We don't care. Right now, we know that bottom number is bigger. Okay? So 0.735224, that's bigger than that top number. Okay? Guys, length doesn't matter at all with these decimals. You just sort of go left to right, and as soon as you find a difference in the digits, game over. All right, here, try this one. Let's see what we got. Check out these 2 guys. Why don't you take a moment, and if you want to pause, just go through it, check it like alphabetical order with words, and I'll meet you back. We'll see where we end up. Okay, well, in the tens place, it's a tie. Hundreds place, tie. Thousands place, tie. Jeez, okay. 10,000th place, tie. Next place, ooh, game over. All right, there it is. 9 is bigger than 8. So therefore, that top number, that's the bigger one. Game over. Very simple. All right, just line those guys up. It's excellent. Okay, it brings up, Wait a minute, you know what? My producer is telling me one more example here. All right, just to make sure. Check this one out. 0.34 and 0.3472. All right, well, check them out. Tenths, it's a tie. Hundredths place, tie. So we move on, but wait a minute. What's going on here? The guy didn't even show up. Well, you and I know from before, right? We could put a 0 there and it wouldn't change the value of that top number. Now it's a comparison we can make. What's bigger, 7 or 0? All right, clearly 7, game over. That bottom number is bigger than the top one. I put the top one back in its original form there, 0.34. Okay? Awesome. Awesome job. All right, here's a related matter. And it turns out that this is a big deal. Later on in mathematics, this idea that you can get numbers in between any two decimals, any different decimals, turns out to be really a big deal. But they're asking us to find a number in between these two numbers, 0.34 and 0.38. Okay, so 34 hundredths and 38 hundredths. Well, you guys know how to get this, right? Something between 34 hundredths and 38 hundredths? Well, how about 35 hundredths? Okay, we got lots of choices, like 36 hundredths. That would work. 37 hundredths. All right, see how easy it is to find those numbers in between? Okay, there was a little bit of daylight there that we could see pretty clearly those guys in between. How about this? 0.34 and 0.347. All right. Well, if you look in the tens place, it's okay, kind of tie. Hundreds place, kind of a tie. There you go. Okay, now we got that missing digit again. I'm going to throw that in there. Wait a minute. Look how clear this is. Now we're talking 340 thousandths versus 347 thousandths, and we're looking for some numbers in between. Well, if you think of it that way, we're all good. We could do like, how about 341 thousandths, 342 thousandths, 343, 344. Keep going, right? 5, 6. All right. You seeing the deal? All right. Even when they look so super close like this, check this out. 0.34, 34 hundredths, and 35 hundredths. Ooh, it doesn't seem like there's any space there at first glance, right? Between 34 and 35? But wait, what if we took advantage of that big fact, that boxed fact that we had before? What if we put zeros in that thousands place? Now look at this. We have 340 thousandths versus 350 thousandths. Man, we got lots of space. Like, how about 0.341, right? 341,000 or 342, 343 thousandths, 4, 5, keep going, 6, 7, 8, 9. Whoa, man, we got lots of room. Just pick one of those, okay? Pick one of those and you're good. All right. I think we noticed something pretty big here today. Even when it doesn't look like there's any daylight between two different decimals, you can find a way to really see that there's lots of room in between them. All right. I'll let that sit with you for a little while. Excellent work today. All right. I can't wait to get back with you in our next lesson, and we'll continue on. We are inching closer and closer to figuring out the real nature of those real numbers. I'll see you then.